Okay, so today we are going to talk about the exponent law. If you took the 11 college recently, you probably are familiar with all of these laws that we're going to cover right now. So we're going to start with basically defining what an exponent is, or what's a power expression. So a power expression is an expression made up of two parts. We have the base and the exponent. Okay? So if we're looking at the first one, 5 to the power of 4. What is your base? What is your exponent?
5 is the base and 4 is the exponent.
How about -5 in brackets to the power of 4? So the base is -5. Why is the base -5 and not only 5?
Because it comes 4 over.
It's in brackets. That's right. Because it's in brackets. Okay? Because whatever is inside the bracket, that's your base. Now x to the power of 3, what's your base, what's your exponent?
X is the base, 3 is the exponent.
7 to the power of -3.
7 is the base.
-5 to the power of 3.
Oh, that, no?
It's just 5.
Yeah.
So your base is just 5. What is the base just 5?
Because there is no multiple power there.
There is no bracket, that's right. So what happens here is, basically this is -5 times 5 times 5. Okay? So your answer for this is going to be -125. Right? Now, if in this case, with an exponent of 3, it's not going to matter. But if this was an exponent 4, right? If you do this, let's say if you had this and you had this, right? The difference is this one is going to be -125. This one is going to be positive 125. Okay? Because this one right here is -5 times -5 times -5 times -5. Okay, so negative times negative is positive, times negative is negative, times negative is positive. Okay, so this is where the difference is going to be, like it's going to make a difference. Okay, if you use a 5, your exponent is at 3. What's your base for 3x cubed? 3x is your base, and your exponent is 3. So we know that a power is a repeated multiplication of the base an exponent number of times. We just talked about that, right? So if I have, let's say 5 to the power of 4, that means it's 5 times 5 times 5 times 5, 4 times, right? So it's a repeated multiplication of the base exponent number of times. So 5 to the power of 4, I just said that, means this. -5 to the power of 4 means -5 multiplied by itself 4 times. If the multiplication or the exponent is not shown, its value is 1, right? So if I have x is the same thing as x to the power of 1. 2 is the same thing as 2 to the power of 1, right? So if the exponent is not shown, it's a power of 1.
0 is 1 over. is 1 0, it's 1.
The answer
Whatever
is
it is,
1.
1.
If your power is 0, then your answer is 1. Yeah, we're gonna talk about
Maybe your senses are height, but
Okay,
many nutrients get from studying the class and it's condition.
let's start with the first law, and it's called the multiplication. Okay? So when I multiply powers with the same base, this is the important part. The base have to be the same. If the base is not the same, then you can't use this law. Okay? I do what to the exponent?
Plus.
Okay? So, if I have 5 to the power of 5 times 5 to the power of 4,
Exponent 1.
so I add the exponent, so that will be base 5 to the power of 9. The base stays the same. What can you tell me about this? Yep. Can you explain it to us?
Multiply with 2 by 4, and we have 1 with 2.
So basically what you're doing here is doing 2x times 4x squared. When you have something like this, you can multiply your 2 and 4. Right? 2 times 4 is 8. This is what you're doing. So you multiply your coefficient. Okay? So 2 times 4 is 8. Now what I have left, I have x times x squared. Right? This is a multiplication, same base, I just add my exponent. My exponent here is 1, 1 plus 2 is 3. Okay? So you multiply your coefficient, add your exponent for the base. Now, when I divide the power, or divide powers with the same base, I do what to the exponent?
Minus.
Subtract. Okay. So there is a reason for all of these, and if you remember from grade 11, we talked about this. And the reason, for example, for the multiplication, if I have this, I have 5 times 5 times 5 times 5 times 5, right? That's the first part. Then I'm gonna multiply another 4 5s. I don't know how many I have, 1, 2, 3, 4, 5, 6. Right? If I look all together, right? All together you have 5 to the power of 9. That's why we add the exponent. There's rules for it. There's reasons for these rules, right? When you're dividing, you subtract because you're gonna simplify, right? You're gonna cancel them out. So I'm not gonna do this because that's huge. It's gonna take me forever. But let's do another example. So if I have, let's say, 2 to the power of 4 over 2 to the power of 3, right? If I subtract my exponent, I'm gonna end up with what? 2 to the power of 1, right? Which is 2. If I actually wanna do it, this is what I have. On the top, I have this. On the bottom, I have this. If I simplify, I'm going to end up with 1, 2. That's why they came up with this rule. There's a reason for it. Okay? So, what would be my base here? What would be my exponent?
Minus 6 is base.
And exponents are 10 and minus.
12. Minus 6, 12.
Okay.
Exponent 12.
So, the base is minus 6. The base does not change. The base is negative 6. It does not change. What am I going to do with my exponent?
Minus 10.
Subtract them. So 10 minus negative 2.
Is 12.
So I'm gonna end up with 12. Because negative times negative gives me a positive.
So if we have minus 6 exponent again without the brackets.
Without brackets.
Yes.
So if you have, what? Can you tell me what?
Minus 6 exponent again
Uh-huh.
divided minus 6. Brackets exponent.
Brackets?
Yeah.
Brackets like this?
Yeah.
Okay.
Exponent minus 6.
You can't simplify it because your bases are not the same.
Oh.
Okay, because your base here is 6, your base here is negative.
So I put without the brackets.
Without brackets, so if you have this,
It's positive. We have 6 positive.
right?
Yeah.
Okay. The negative and the negative, they're gonna cancel each other.
Yeah.
So they become positive. And then it will be 6 to the power of 12. Okay? Remember that your bases have to be the same. Okay.
This one's
What are we gonna do with this? So I have 3x to the power of 4, y to the power of 5, all divided by 6x squared y.
We cancel first x, exponent 4, and then x square. Cancel the squares. We can just move the x up square.
Okay.
And y,
Mm-hmm.
it's going to it's become only y exponent 4.
Mm-hmm.
We have 3 and 6, we can 1 and 2.
Okay.
2.
So your answer is gonna be x squared y4 divided by 2, right?
Yeah.
Okay. So let's start with the numbers.
Yeah.
Okay? How can I simplify 3 over 6?
1,
1 over 2.
2.
Right? Because they're both divisible by 3, I can simplify them as 1 over 2.
Oh shit.
For the x's, I have 4 minus 2. So what do I get?
X square.
X squared, because I'm subtracting 4 minus 2. For the y's,
Yeah, 5 minus 1 is
5 minus 1 is
4.
4. So your answer is x squared y4 over 2. Okay? So if you want to write this neatly and so it looks nice, basically this is how it should look. Are you okay with this? At the back? We're good? Now, the third rule is power to the power. Okay, so if I have something to the power and then another power, so I'm raising it to 2 powers. I multiply. Okay? So as you can see right here, I only have one base. The base is not going to change, it's going to stay 3, for example.
20.
And then to the power of 20. All of these rules, you'll see them on that board right here. So you can follow these rules. And they will also be in your formula. Do it.
More is 21. More is x.
So I keep the bracket.
Yes.
So it's going to be minus x to the power of 21, keeping the brackets. Okay? Because your base is inside that bracket. So far we have the multiplication law, which is if you're multiplying, you add your exponent, keep the base the same. Division law, if you're dividing, you keep the base and you subtract your exponent. Power to the power law is if you have power to the power, you multiply your exponent. Okay? Okay. So power of a product or quotient. To simplify, a power of two or more items multiplied and or divided. This is where you have to be careful. This is only applied if your base is being multiplied or is being divided. Then I distribute the exponent of each item being multiplied to each item being multiplied and or divided. What that means? If let's say you have a b to the power of x, then your answer is a to the power of x, b to the power of x. Okay? So the x gets distributed to every single term that is multiplied. Okay? Now, let's look at this. I have negative 3 x to the power of 4 to the power of 3. How would I do it? Mm-hmm.
And the 4 exponent 3 powered by 3.
So the 3 is going to get distributed to the negative 3, and it's important to put it in brackets. Then you have x to the power of 4 to the power of 3. What happens there?
So I saw minus 27 x 12.
Yes, but first you have to show me this step. Okay? So Ila was asking, can I right away write the answer, which is negative 3 to the power of 3 is 27, is negative 27. Yes, you can, but you have to show that step. Same deal if I have a divided by b to the power of x. That's the same thing as writing a to the power of x over b to the power of x. Okay? So again, I'm distributing that exponent to every term inside the bracket. So let's see what do I get.
4 squared, y 10, and 6 squared.
Okay? Everything got that squared. Okay? 4 squared. 5 times 2 is 10. 6 squared. 2 to the power of 2 times 2 is 4. Okay? So every single term got that squared exponent.
So is that here or should we writing equal?
If I'm asking you to simplify, you're going to have to simplify that.
Oh.
Okay? And then to simplify that, you actually have to do 4 squared, which is 16, y 10, over 36, x 4, and then you have to simplify. Okay? But if I don't ask you to simplify, then you don't need to do that. Now, anything, no matter what it is, a letter, a number, a billion, a gazillion, no matter what it is, if you raise it to the power of 0, is equal to 1. Okay? That will be your final answer. As simple as that. Okay? Anything. And the reason for that is, look at this. If I have x to the power of 4 divided by x to the power of 4, what do you get?
1. 1 is 1.
Because you simplify, right? You cancel these and you simplify and you get 1, not 0, 1. Okay? Okay. Now, what other ways can you solve this? I have same base and I'm dividing. What do I do with my exponent? Subtract. So x 4 minus 4, what do I get when I do 4 minus 4? And then I say that this is equal to 1. Right? That's one. That's why anything, no matter what that is, could be an expression, could be a letter, could be a number, it's the power of 0 is equals to 1. So as you can see here, I have 3x squared y to the power of negative 6 to the power of 0. Right away, without doing any work, I can say equals to 1. How about here? 1. Okay?
You want to come up here?
Now negative exponent law, any base raised to a negative exponent is equal to the reciprocal of the base raised to the same positive exponent. What does the word reciprocal mean? What does the word reciprocal mean? The flip, right? Reciprocal means your denominator becomes your numerator and your numerator becomes your denominator. Okay? So it's when you're flipping your base. Let's look at this one first. Let's look at the second term first. So I have 1 over 5 to the power of negative 2. I have a negative exponent, right? If I flip the base, what does it become? 5 over 1. I'm talking about 5 over 1, right? And then to the power of 3. Right? Flip the base, make your exponent positive. Okay? This can be as simple as being 25, right? Because 5 to the power of 2 is 25. I don't really need to write my denominator because it's 1. Now, how about first one? 3x to the power of negative 4, y to the power of negative 3, z.
Yes, and then 1. I can just 1 and then 1 up and
Over.
yeah. Because it seems like everything there is and then 1.
So everything is over 1.
Over 1, yes.
But is this the power of a negative
it's not power,
exponent?
no.
Is this the power of negative exponent? So do I need to flip these?
No.
No.
Because we don't have the exponent.
So if you look at this, the only two that have a negative exponent are the x and the y, right? So these are the only two that I need to flip. Technically, when I'm flipping, I'm bringing them down to the denominator. Okay? So you can write them like this: 3z over, because now I bring it down to the denominator.
4 y.
Okay? Or if you want to think about it like this, I'm flipping this, so that's going to be 1 over x4. Flipping this, that's going to be 1 over y3, and then z. But this looks much more complicated than it should be, right? This one is much neater and much cleaner. So all what you have to do, if you only have one term that you need to bring it down, you need to flip it, you just bring it down to the denominator, and you make it positive exponents.
You multiply 4 by 15.
Okay? I'm going to erase the other one just because it looks too complicated.
And multiply, I mean, yeah, the sum of this are the product of that.
So these are the laws. I'm going to write them down. You can copy them.
Yeah.
So now you have to prove factor. Take that group, take this group. What's common for, what's the greatest common factor? And these two greatest common factor. I'll do it for you. 4x is your greatest common factor. So 4x. 4x. It's 4x plus 12, right?
So we just did this stuff, right? We were just doing
That was an example.